Hello everyone, how do you do all? So I hope you are well and your studies are also well. So after many days, so I come back. So please subscribe my channel. Please watch my videos regularly. From today onwards, if it is possible, every 1 week I will make videos and I will upload the videos every Sunday or Monday. So I am explaining the topics as per the chapter wise. I already explained some chapters. Please watch the videos accordingly the chapter which is going in your school or in your class. So previously the chapter human eye and the colorful ball we discussed structure and function of human eye and defects of vision, myopia, hypermetropia and dysphobia, cataract. So today I am going to start my session with problems related to eye defects. To rectify either myopia or hypermetropia or hypermetropia, we need to use some lenses. So what type of lens we have to use and what the power of lens. Let us discuss how to calculate the answer, how to find the answer if an exam asks some problems regarding to defects of vision. Let's take the first problem. A person suffering from the eye defect, myopia, can see clearly, only up to a distance, of 2 meters. What is the nature and power? What is the nature and power of lens required to rectify this defect, right? A person suffering from the eye defect, myopia, can see clearly objects up to a distance of 2 meters. What is the nature and power of lens? So in this way the problems are given in examination. So let's understand myopia. So to know how do we rectify the myopia, let's know what is myopia. Myopia is a defect of vision due to a person cannot see the far or distant objects clearly, but he can see the near objects. So a person suffering from eye defect, myopia, can see clearly only up to a distance of 2 meters. What is the nature and the power of lens? So what is the nature of power of lens? Let's know. For a person suffering with myopia, suffering with myopia equal to infinity. Absolute distance u is equal to infinity. Then image distance v is equal to minus 2 meters. Minus 2 meters. Right? Then focal length. Focal length f is equal to, we need to find, and also find the power, of lens. To know power of lens, need to find the focal length. So the far point for myopia, the person who is suffering with myopia is minus 2 meters. 2 meters. So we know the formula. 1 by f equal to 1 by b minus 1 by b. First know the focal length. Object distance is infinity generally. So a person cannot see the far objects but able to see the nearer objects. So this real distance is nothing but the far point in front of the lens. Image distance d is equal to far point in front of eye lens. So the image is formed at 2 meters. When you place the object 2 meters. So far point for IOB person is 2 meters. Means able to see the object up to 2 meters only. After 2 meters the person is unable to see the objects. So substitute the values. 1 by f is equal to v. So 1 by minus 2, that's minus 1 by infinity. Okay, right? So 1 by f is equal to 1 by minus 2 minus 0, because 1 by infinity is equal to 0. So you can write 1 by f is equal to minus 1 by 2 minus 1 by 2. From this you can write focal length f is equal to minus 2 meters. Focal length f is equal to minus 2 meters. So then what to find? What is the nature and power of lens? As we know, to rectify the myopia, defect of vision myopia, we have to use concave lens. So, to rectify the defect, we should use concave lens. So, what is the nature of the lens? Concave. Then coming to the power. Power P is equal to 1 by f. Power P is equal to 1 by f. That is equal to what we need? Fp. So f is equal to 1 by p. So P is equal to 1 by f is equal to 1 by minus 2. 1 by minus 2. So P is equal to, you can write 0.5. You can write 0.5 diameter. So power of the lens. So need to use concave lens, and the power of concave lens is minus 0.5 diameter. So diameter is the unit of power of lens. So a person suffering from the eye defect myopia can see clearly only up to a distance. How much Then what is the power of concave lens to rectify this eye defect is minus 0.5 diameter. Minus 0.5 diameter. So read the problem twice or thrice and understand the given values. Understand the problem. So what type of defect is given? So what type of defect is given? Then you know what type of lens you have to use to rectify the defect. And to rectify the defect of vision, you need to use spectacles. So the spectacles contain some power. Like using concave lens or the convex lens. So the power lens has some power. So no. What is the power of power? So reciprocal of focal length. So this is our one problem. Then coming the second one. Second problem. The near point of a person, the near point of a person suffering from hypermetropia is at 50 centimeters. 50 centimeters from his eye. What is the nature? And power? What is the nature and the power of the lens? What is the power of the lens needed to correct this effect? So assume the near point is equal to 25 centimeters. So hypermetropia, hypermetropia is a eye defect. Hypermetropia is a eye defect of vision due to which a person cannot see near objects clearly but able to see the far objects. Because in case of hypermetropia, the image is formed behind the retina. To rectify the problem, hypermetropia, what type of lens you have to use? Convex lens. So what is the nature of eye lens used to rectify this problem? Is convex lens. So the real point of a person suffering from hypermetropia is at 50 centimeters from his eye. In this problem, assume that the real point of normal eye, human eye is equal to 25 centimeters. So the 25 centimeters is nothing but the least distance of restricted vision. So we are assuming that generally the near point for the human eye is 25 centimeters. If the person is suffering with the hypermetropia, he is able to see the object if the object is 50 centimeters away from the human U is equal to minus 25 centimeters. Minus 25 centimeters. Image distance V is equal to how much? Generally 50 centimeters. So the person is able to see 50 centimeter distance. So to know the power of x, let's find out the focal length. F is. So calculate the focal length from the formula 1 by F is equal to 1 by V minus 1 by V. Substitute the values, please. Minus 1 by minus 50 minus of minus 1 by 25. That's equal to minus 1 by 50 plus 1 by 25. So let's take LCM. So 50 over 1 plus 2. That is equal to V by minus 50. So 1 by F is equal to minus V by 50. Minus V by 50. Then from this we can write focal length F is equal to minus 50 by 3. Minus 50 by 3. Then calculate, then we get minus here. So 1 by 50. 1 by 50. So focal length F is equal to 50 centimeters. 50 centimeter. So this can be write 50 centimeter is equal to 50 centimeter is equal to minus 0.5 meters. 0.5 meters. So focal length of the lens is 0.5 minus 0.5 meters. Then calculate the power. Power P is equal to 1 by F. Power P is equal to 1 by F. That's is equal to 1 by minus 0.5. Minus 1 by 0.5. That's equal to 1 by minus 5 by 10. That's equal to 10 by 5. 10 by 5 is equal to minus 2. So the power of lens is 2 diagonals. Minus here. So plus 2. Power of lens is equal to 2 diagonals. What type of lens we have to use? We use convex lens. So convex lens for rectifying this, for correcting. So convex lens is used to correct this defect. So understand like this. So two problems are discussed. One is regarding to myopia and another one is regarding to hypermetropia and so the two problems, focal length we need to find and calculate the power of lens. If the power of lens is given, then how do we calculate the focal length? So based on the focal length, we know it is easy to take concave lens or convex lens. Observe that for a convex lens, but focal length is positive. And whereas in case of concave lens, focal length is minus. So in this way we can understand the problems regarding to eye defects. So myopia and hypermetropia. So sometimes the problems are also given based on this. To know the nature of eyelids, the nature of the lens One more problem. Let's take this one more problem. A person needs a lens of power, minus 5.5 diopters for correcting is distant vision. Correcting for is distance vision. For correcting is near vision. For correcting is near vision. He needs a lens of plus 1.5 diopter. What is the focal length? Of the lens required for correcting distant vision and near vision. Distant vision and near vision. So previously we calculated focal length and we calculated the power. In this problem the power is given of a lens. Let's calculate the powers and the focal length. Let's calculate the focal length of the lens for correctly distant vision. And second one is near vision. So minus 5.5. So what type of lens it is? So the power of lens is minus. The power of lens is minus and it is a concave lens. It is a concave lens, and so we use concave lens for rectify the eye defect myopia. So distant vision here the distant vision means just myopia. To rectify the eye defect myopia, if you use the lens has the power minus 5.5 diopter. Then calculate the focal length for this lens. Similarly, for near vision, this means hypermetropia. So, which lens you have to use to rectify hypermetropia? Convex lens. So, the power of convex lens is plus 1.5 diopter. So, in both cases, we need to find the focal length of lenses. So, solution for first one, for distant vision, to defect to distance division. So what is the focal length of the lens? Right? Power of lens. Power of lens. P is equal to minus 5.5 diameter. So means it is a concave lens. It is a concave lens. Then find the focal length. Find the focal length. F is equal to. We know P is equal to 1 by F. P is equal to 1 by F. That's equal to, from that we can write F is equal to 1 by P. So substitute the values. So F is equal to 1 by minus 5.5 minus 5.5. This should be written as 1 by minus 55 by 10. 50 by 5, 10. This should be written as 10 by 55. 10 by 55. So focal length F is equal to minus 10 by 55. After by simplification, we get minus 18.18 centimeter. So focal length of concave lens. Focal length of concave lens used for rectify or correcting the distance division. Nothing but myopia. The focal length is minus 18.18 centimeters. The power of lens is minus 5.5 diameter. Then for second case, near vision. For near vision, power of lens, nothing but convex lens. P is equal to plus 1.5 diameter. So convex lens is used to correcting the eye defect hypertension. So focal length F is equal to, need to find the focal. So we know P is equal to 1 by F. P is equal to 1 by F. So from this we can write F is equal to 1 by B. That is equal to 1 by 1.5. So F is equal to again we can write, so 1 divided by 15 by 2. That's equal to 10 by 50. F is equal. So after the multiplication you get 16.66 centimeters. 16.66 centimeters is the power of convex lens which is used to correcting near vision. And focal length of lens concave lens is minus 18.18, which is a concave lens used to rectify distant vision. So these are the problems regarding to eye defects. So light chapter, we calculated problems regarding to concave and convex mirrors, concave and convex lenses, and refractive indexes, and problems regarding to convex and concave lenses. So calculating focal length, image distance, object distance, the nature of the image, so where the image is formed, at which point the image is formed. These problems are very important, right? So and again we have to revise sign convention rules. Why we have to use why we write minus for object distance, why we write plus for focal length. So like that. So for that, so read the sign conventions rules. Read sign conventions rules again and understand that why take it. The first problem. So the first problem taken as object distance is minus. Object distance is minus for a concave mirror, for a concave taken as a minus. So sign convention is good, you have to revise. Then you will be able to understand problem. So these are the problems. So practice the problems by changing the values, or practice problems by seeing your textbook and example problems after the chapter we have some question and answers. So those are some problems are given. So try to solve those problems and you will become perfect in solving the problems. Right? So thank you. So this is